Good afternoon. Today I'll be talking about radiation physics. So radiation physics is nothing but it is the study of production of X-ray and how your X-ray machine works. So today I'll be talking about both the working of X-ray machine and how your X-rays are produced within your X-ray machine. Coming to X-ray machine. So basically there are two components or two parts in your X-ray machine. The first component is your X-ray tube, and second component is a power supply. And this X-ray tube, it is positioned within your tube head. So this is your X-ray tube head, and this is your control panel, which is connected to a power supply also. So this control panel help us to change to allow the operator to adjust the time of exposure and the energy and the exposure rate of the X-ray beam. Now coming to each component in detail, that is first part is component is your X-ray tube. So your X-ray tube again it contains two components, that is cathode and an anode. This cathode and anode they are situated or positioned within the evacuated glass envelope or a glass tube. So the function of this glass envelope is it is leaded from inside and it prevents the radiation leakage. So whatever the X-rays are produced, they will be divergent and the leakage of this radiation will be reduced or it will be restricted with the help of this glass envelope. Yeah, now coming to detail about the cathode. So cathode, it contains a filament and a focusing cup. So the filament, it is nothing but it is the main source of electron within the tube. And this filament is made up of tungsten wire, which is about 0.2 centimeter in diameter and 1 to 2 mm wide and 0.1 to 0.2 mm thick. And its length is 7 to 15 mm in length. And this filament, it is held in position on both the side with the help of a two stiff wire. And this wire usually carry a current when your X-ray machine start working. So when the X-ray machine start working, this wire will be carrying a current, and through this current, this filament is heated to incandescent. And when it is heated, your electrons are produced. Now coming to the focusing cup. So once your electrons are produced by the filament within the cathode, next focusing cup will be coming in action. That is, the function of this focusing cup is it focuses all the electrons which are emitted by the filament within the cathode onto a rectangular area in an anode, which is called as a focal spot. And this focusing cup, it is negatively charged and it is made up of molybdenum. So next coming to anode. So this anode, it consists of a tungsten target or a target within this, which is present or embedded in a copper stem. So the function of this anode target is the when electrons are produced within the cathode, they are directed towards the anode through the focusing cup, and these electrons go and hit this target. So the function of this target is to convert all the colliding energy of the colliding electrons into an X-ray photon. So when these electrons go and hit this target, the kinetic energy of this colliding electrons will be converted into X-ray photon. And this target is mainly made up of tungsten. So tungsten is the preferred material for target in the anode because of this reason, that is, it has high atomic number. So because of high atomic number, it is more efficient in production of X-ray. It has high melting point. So during the process of production of this electrons and X-rays, the heat within this machine will be, the temperature will be raised. So because of its high melting point and thermal changes within this, it will not render the tungsten to melt, and it has low vapor pressure so that it will, even at a high temperature also, it will not evaporate, and it is a good thermal conductor. So because of these reasons, tungsten is the preferred material for target in the anode. So Once your electrons are produced, they go and hit onto the target on the focal anode, which is a area which is called as focal spot, and X-rays are produced. So this focal spot within the anode, thus it plays an important role in increasing the sharpness of the radiographic image. How means the smaller the size of the focal spot in the anode, increased radiographic sharpness will be there. So because as your anode size of an actual focal spot size is 1 into 3 mm, because of its larger size, the sharpness of the radiographic image will be reduced. So to take advantage of this, what they do is this target is slightly inclined to 20 degrees so that the effective focal spot size became 1 into 1 mm. So that with this inclination, the size of the focal spot size is also reduced, and the surface area which is available for the central beam or X-ray beam will be larger, so that the distribution or the dissipation of the heat which is produced during this process will also be reduced. So apparently all of this will result into small apparent focal spot size and increase in the image sharpness and improved heat dissipation. So in brief, that is this picture which illustrate or which shows the components of your X-ray tube or X-ray machine. So in this picture, you can see this is your cathode and this is your anode. Okay, and this is your glass envelope. Okay, so your cathode contains two components, that is your filament and a focusing cup. This filament is held in position with the help of a two-step wire. So this wire will be carrying current. So when they carry current, this filament is heated and electrons are produced. And when the electrons are produced, your focusing cup, which is also negatively charged, and the electrons are also negatively charged, they are repelled, and this focusing cup will direct this electron onto a rectangular area in the anode. This is the area which is called as focal spot or target. So once these electrons go and hit this target, the kinetic energy of this electron is converted into X-ray photon. So you can see here, this is a rectangular area which is called as target, and this or the area where the electron hits is called as focal spot. So they have inclined this instead of making it straight, they have inclined it at 20-degree angulation so that the focal spot which is available will be smaller in size and the larger area, surface area is available for the electrons to go and hit, so that heat dissipation will also be proper, and there will be efficient conversion of the kinetic energy of this electron into a single useful beam also will be taking place with this. So with the inclination of this focal spot, the effective focal spot size becomes 1 into 1 mm, whereas the actual focal spot size is usually 1 into 3 mm. So that is how your X-ray machine works. Now coming to the production of X-ray, how does X-rays produce? So what are the process or what is the process through which X-rays are produced? So X-rays are produced mainly by two mechanisms or a process which is called as Brandstrom radiation and the characteristic radiation. So majority of the X-rays, photons from the X-ray tube are produced through Brandstrom radiation only. So what is a Brandstrom radiation? So it is also referred as Bragg radiation or deceleration radiation. So what it says, when a high-speed electrons they are produced, they go and hit the tungsten target, and they interact with the nuclei of the atom of the tungsten target by two ways, that is by direct hit and by indirect hit. So what is a direct hit? So direct hit says that these high-speed electrons, they directly go and collide head-on with the nuclei of the atom in the tungsten atom. So they directly, these electrons, whatever the electrons are produced, they go and collide directly with the nuclei of the tungsten atom. And the total kinetic, and this results into the conversion of the total kinetic energy of this high-speed electron is converted into a single X-ray photon. So here you can see in this picture, which says these high-speed electrons which are produced, they go and hit directly onto the nuclei of the tungsten target, and then the kinetic energy of this is converted into a single X-ray photon when they go and directly hit or collide head-on with the nuclei of the tungsten target. So this results into production of an X-ray photon. This is your direct hit. Now coming to the indirect hit. So you can see in this picture, so you have when the electrons are produced, they are directed or they are attracted towards the nuclei of the tungsten atom. So the moment they go nearby to this nuclei of the tungsten atom, what happens is they tend to deflect from its original path. And this deflection of the electron results into production of an X-ray photon, which is shown in this picture. That is your near miss. So near miss is nothing but when the electrons are produced, they are directed towards the nuclei of a tungsten atom. When they go nearby to the nuclei of a tungsten atom, because of the driving forces, what happens is they tend to deflect from its original path and they get deviate towards the other path. So this deflection results into release of certain amount of energy which is given out as a single photon. So this is what is your Bremsstrahlung radiation, that is product that through which your X-rays are produced by direct miss and by near miss. Coming to characteristic radiation. So the characteristic radiation states that, so here you can see in this picture, so your atom has a nuclei which is present within the center, and surrounded by this nuclei will be your electrons which are arranged in a orbital shells. So what happens is when the electrons are produced within the X-ray machine, filament, when the electrons are produced by heating up a filament, what happens is they go and hit the electron in the outer orbital shell of a target material. So what happens is when this electron go and hit onto the outer orbital shell of the target material, it results into displacement of electron from this orbit. So as a result of which there will be a void or there will be an empty space which is produced because of the displacement of electron, because of the electron which go and which comes and hit this electron. So because of this empty space which is produced, what happens is the electron from the outer orbital shell, they tend to get displaced and it gets to shifted towards the inner orbital shell to fill that void. So during this process of during this process of shifting from outer orbital to shell to inner orbital shell, there will be a release of certain amount of energy which is given out as a single X-ray photon. So this is how your X-rays are produced and this is how your X-ray machine works. So with this, I would like to conclude. Thank you, one and all.